So, welcome to this Lunch and Learn session. Thank you all very much for joining. I like to share with you a bit what we have been doing in business and intelligence and reporting, and more specifically when it comes to GenAI. A little bit about Fisch. We are a mid-sized asset manager, about 6 billion AUM, specialized in convertible bonds, corporate bonds, and multi-asset funds. Client base mainly are institutions in the DACH region, but we do also have retail share classes. Now, about me, I've only joined the finance industry since about 5 years. Before that, I've started as a software architect and was doing that kind of work already before. Nowadays, I'm heading client reporting and BI team. And even earlier, I was a researcher and did a PhD in software for supercomputing, specialized in weather prediction running on GPUs. So even back then, actually, we were running tasks on the hardware that is nowadays powering AI. So it's all coming back nowadays, right? Agenda of this talk. First, I'm going to give some introduction about reporting at Fisch, in terms of tasks and numbers and what we are doing with automation. And then generative AI for BI and reporting. How do we get there? What is the idea? Demo, what were our pitfalls? What can we learn from all of this? And then a future outlook. So our reporting, what we do for the company is, I would say, roughly in 4 different categories of tasks. One is standard reports. For one thing, about 345 fact sheets with 3 pages each are generated each month. We also have portfolio reports, exactly 26 per month, and they are roughly about 30 pages. Custom client reports, I've just counted this morning, in the last quarter were 178 of very varying sizes. Some of these just take half an hour, some take a day. Internal reports at 100 per quarter, and then finally, since end of last year, we are doing sales presentations as well. At least the technical setup and the generation of it, of course, it needs a lot of work also from the product team, namely Corinne, Günther, and Yannick. And then I've also done a workload analysis in Q2 last year. And back then, we were already generating about 14,600 tables and graphs every quarter, with a team of back then 3 reporting specialists. So obviously, this is not possible if you don't have a certain amount of automation. And the estimation from that analysis was that about 12,800 of those 14,600 were already automated. When we talk about automation, that means we need a certain technical setup. I will briefly discuss it here because it becomes a bit relevant after as well. So we have various data sources. Mainly, of course, Aladdin BlackRock, which is our portfolio management system from which we extract data on a daily and monthly basis. We have our own, I'm calling it funds database here. For most of you, this probably will be familiar still as Fish Tank. This is basically our legacy data warehouse where we had previously all our data. And nowadays, it's mainly funds, static data, as well as NAVs that are in there. Then we have various other sources, often in Excel format, CSV format, what have you. They all get integrated in one consistent API layer. We call it reporting API, or internally Poseidon. And then from there, we have a common way how we can grab data and put it into a report, and that is the export layer. We mainly base our reports on PowerPoint. So we have a whole lot of PowerPoint templates that get loaded into the system. Then basically all the linkages to the data will be extracted, and then with some parameters, we generate these reports, as you see here, examples, fact sheets, portfolio reports, and sales presentations. Now, there are two core ideas here I want to highlight. When it comes to the report generation, we solve this, as I said, in PowerPoint templates, and we do it in a way where each table and or graph and or text box is behind the scenes linking to a certain data object. And we use actually only native PowerPoint tools for that. Maybe you have at some point seen when you use PowerPoint a bit more in an involved way, there is actually a place where you can give a name to a table or a graph or any object in it. It's called the selection pane. And that's where you can give names. And with those names, what we do in these documents is we link it to the data. And this way, when you, for example, copy and paste, let's say, a graph from one PowerPoint to the next, the linkages, they stay the same. So it would still work as a new template. When you compare this to many other reporting engines we have evaluated in the past, there it's usually you have to set everything up from scratch in some kind of web interface, for example, and it's just a lot of work and also not very flexible to do what we needed it to do. And in the end, we basically decided on this for fact sheets, and from there it grew into these other report types. The second core idea is that when we grab data for reporting, we always grab the data using a specific web address, which gives you what type of data you need, and then the parameters such as which account, which date, and so on. This is all part of this address so that the data can be used not just in these reports, but in other ways. For example, you can send automated emails. We can extract it as an Excel for ad hoc purposes, and so on. This is how this interface for us internally looks like. Each web address, as we have it, it is described with an API description. And with this description, we then generate this interface. And when you open one, you can, for example, see all the parameters. You can see a little bit of text to describe it, and so on. Now, this looks very technical, right? And it's mainly used internally in the team, but it's important for you to see this for later understanding of how we kind of supercharge this now with AI. Now, if we just take fact sheets as an example, this is how in the end it looks like. From the left side, you see the template coming in, parameters. Here it's date, account, and share class, and language. Then you have the API, which actually gives you the data. And the export layer puts this all together and gives you a report in the end. I can show at this point a sales presentation template. This is what I meant with this selection pane. That's what it's called, like at least in the English versions of PowerPoint. You see here that, for example, this graph has a specific technical name, and that's how we link it behind the scenes to our data. To note is that the template itself almost looks like a finished report, right? It's not, when you typically have templates, you have often magic strings which do certain things to then grab data into this report. But here it already looks like a report. We have sample data in it. That's very helpful for the formatting, so that you, for example, can always see how will the colors of the graph look like in the template. You can see for a certain amount of text, will it still work? Will it break over, let's say, or hide the text behind somewhere? So that's has proven to be a helpful approach, also which we haven't seen in other products, basically. So with this technique, as I said, we automated most of the objects that we generate on a quarterly basis. And the tendency is growing. So, for example, in these numbers above, the sales presentations were actually not yet included. And we also see that automation helps quite a bit with quality as well. So there are less manual touches needed. when you have a problem, you often can solve it for good. You see that there is some issue, some edge case that we didn't think about, and you solve that edge case, and it should never reappear. And if it does reappear, we add like a test for it, and then it should never happen at least the third time, right? And yeah, so there's also, as I said, less potential for mistakes, and then also more time for checking. The less time you need for mechanical things to do, you can also spend that time on the checking part of reporting. And yet there are still, thousands of custom graphs. I've showed the numbers. There's a lot of custom reports that need to be done on a monthly basis, and especially for end of quarter reporting. And there's a certain kind of scaling issue with both if we try to grow the business or go more towards finer grained, let's say, sales activities where you go after smaller tickets, you may still want to have a lot of ad hoc presentations of data that may make sense for each particular client. So we basically need a solution for ad hoc reports and BI on the fly, which we haven't quite covered yet. If I may use an analogy, when you think about the sources, they are basically like your wheat field, right? And then we have this reporting API, and I think of this as like a pizzaiolo oven. It's quite good at doing what it does, but you do need a skilled person to operate it. You need this pizzaiolo to be able to make sense out of this data and then maybe put it together in new ways and so on. Then we have the export layer, which is kind of like a pizza factory, which uses also the pizza oven, but then it adds a whole bunch of automation on top to make standardized pizzas on an industrial scale almost, right? We think about thousands of reports every quarter. But what you don't have here is, hey, but could I have margarita with basil on top instead of just with cheese? There's not so much customizability, essentially, to this whole system. And so the question is, how do we get from there to like your pizza delivery service, where you can just call a person and tell what you need, and basically the whole economy works for you and gives you what you need, right? So that's how we arrived at this idea of generative AI. And let me bring you the idea a little bit closer still. So we have this reporting API, this pizzaiolo oven. And one core idea here is what I showed you before, this interface. It's all generated based on text. So we have API specifications. They're essentially text. What comes out of the system are web addresses that you then can follow, and then you get the data, right? Web addresses are just text as well. And what the person wants can also be described as text. Like you enter it in a chatbot. So with this, we basically reduce the problem of ad hoc reporting as a text operation. And it turns out there's something very good that has happened in the last, let's say, about 2 years, where these LLMs that we have seen have become very, very powerful at text operations. Maybe some of you have used it, or many of you have used ChatGPT already, and you have seen kind of the power and the understanding it has of the text that you give it, right? So this led us to the idea. Vladimir, he organized a firm-wide hackathon. He also had the invitation for that. Back in March, it was like late March, we had the event. And there were several goals here. One was, first of all, raise awareness in management, give hands-on sessions for users who are technically interested in this, and then building first experiments using GenAI. We also wanted to kind of enable champions wherever they may be in the company to be able to engage with AWS and to build their skills, and then maybe something grows out of this, right? We already had this idea of the reporting chatbot in mind. We used this as an example, and it turns out actually, yes, it's a good example because of what I am about to show. In the end, basically, I was able to run from there with what we learned in this hackathon and produce a prototype within about 1 to 2 FTE weeks. So it took me about a month in total, but I was only able to work maybe 25% on it, roughly. Right? So let's just get to a little demo of what we came up with. I actually showed this in the town hall, but let me get here into a little bit more in-depth information. So we have this case, right? You have a sales prospect who wants to invest in high-yield bonds, but doesn't want a large exposure in Asia. And the user just asks, you know, how can we make a case out of this? And let Delphi, that's how we call the chatbot, figure out how we can get the data to make a story. And based on these API descriptions that I talked about, it was able to figure out, look, if you talk about exposure, what you probably mean is allocations. And we have an endpoint for that. We have an API. If you talk about Asia, you mean the regional breakdown under this API. Since you say high yield, it figures out from the account information that I meant BH1201, which is the Aladdin portfolio identifier for it, which we use to address the correct data point, because we still actually mainly deal with anonymized data. For example, if you have a mandate, we do not know the mandate's name on purpose, because this system is basically designed so it could, you know, be hosted even with outside of EU borders, let's say. So we don't send any of that information across. So it puts together a link based on that information, and then you can click the link. It will load a bit, and we have here a table which clearly shows you, you know, roughly 2% exposure in Asia. So this fund looks interesting for this particular client. In the same session, we can now ask, this is looking pretty good, but I need a sales presentation now. I want to make a pitch out of this. And again, since the sales presentation is also just an endpoint that we can call, Delphi is able to figure all of this out. From the context from what we had before, we still use BH1201. We use, for the valuation date, a specific strategy. We didn't specify it, so it falls back to the last end of month, because that's where it knows from the sales presentation endpoint, hey, this stuff is available monthly at the end, and then it goes from there. One thing maybe to note is that it chooses German as language, even though we ask in English. That's because German is the default language in our system. But that's maybe something we could improve with a bit more context information. And now you see how it was able to generate this. It was sped up a bit. It actually takes about, let's say, 40 seconds or so to generate this PowerPoint. But still, like, that's better than sitting down yourself for 2 hours and then doing this yourself, right? And here again, we have, among many other things, the breakdown across regions, and see that Asia has a low exposure. So that seems like a fairly good pitch to do. Now, we have, of course, as maybe some of you are aware that this is a problem, we have come across hallucinations, right? What is a hallucination? It's basically when you get unwanted or false responses. When, for example, the system may not have this information, but because you asked in a certain way, it will try to infer, because the way that LLMs work is basically just they take a token of text, let's say a word of text, and just choose the next word, which comes from the training data with the highest probability of, or with some temperature setting, it drops to, let's say, the second or third probability. But just with this statistics game, it's able to come up with good answers for your queries somehow, right? But that also maybe shows you that this may go wrong, because in the end, there's a certain amount of randomness involved. However, the experience is showing that if we give high quality context information and we have, let's say we reduce down the problem space so that all it needs to do is come up with these API queries that should come in a correct way. So it needs to know which endpoint, which parameters, and how to set them. Then actually the error rate goes down and it can become a useful application. So give you some examples. If I ask Delphi, please predict Apple price in 1 week, it basically tells you, sorry, I don't have an API to predict the future, right? And that's good. That's very good. So it means that it doesn't just do whatever. It's really trained to just use the API specifications that we give it to come up with these examples, because that's all we want. We only want data coming out of our reporting API. Don't want it to hallucinate something based on its training data that it has from many petabytes of data that they used in training it. If I say something, I try to trick it up, how is the Fisch equity fund positioned? Again, it understands that the available endpoints mostly cover convertible bond, and multi-asset strategies. I didn't give it this information explicitly. It summarized that from the account information that we give it. For each account, we list kind of what is the name of the strategy, which already makes it understand, hey, what's going on there? What kind of product are we selling? And as I said in the beginning, what Fisch is, right? It's already was able to summarize what this company is about. And that is one of these examples that I really like, because it shows that there is some kernel of deeper understanding in there, rather than just basically blind summarizing text, right? So there's one example I could find where it does come up with an answer. It will create a link. When I, for example, say performance figures for the Fisch Barclays fund. Interestingly, when I say Barclays, somehow from the training, it seems to think that Barclays is mainly involved in the fixed income space, which I think is the case. And they, it then thinks, okay, wait, what kind of fixed income products do we have? There's something called Bond Global Corp Fund. And then it gives you BG101 as account ID. But the thing here is purposefully it's wordy, it explains to you what it's doing. So when using this system, which I hope we will all do very soon, we always need to check, right? Like with a human, we need to check the work. We need to check what it's doing, but at least we have all the information, all the assumptions going into this to be able to verify that what we get is correct. Some a bit more technical nuances. It turns out that context size is a very important factor in success of such a system. So with context, what I mean is when you do a query to the system, we do not do training per se of this model. We take a factory model. It's called Anthropic Claude, and that has been trained, and it's very expensive to do such a thing. It's on the order of hundreds of millions of dollars to train such a model. Okay, we cannot do this as an organization ourselves. But what we can do is within the query. So when we give a question to the system, we then provide all these API specifications, account information, and so on, together with the user question, and that becomes the context. So you actually load a whole bunch of text into it, and that's something maybe the user doesn't see, or you would have to enable it to see, and then it comes up with an answer. But the more you load, the more it becomes a problem of attention. It can be, for example, that when you load, let's say, 20,000 words into it, it will start to forget things that you specified in the beginning. So it's kind of a target conflict in a way. We want as much context as possible, so it could answer a more wide variety of questions, and also we don't have to understand much ourselves before asking it. We don't have to filter or pre-select data to deal with. But then also the error rate goes up, the precision goes down the more we do it. And there's a certain balance we have to find there. Then also when we have larger context sizes, it limits the model choice. So let's say above 8K words or so, we actually on AWS automatically need to use Anthropic Claude. There's also, for example, from Meta, we have Llama, which is an open source model, which is also quite interesting, but it is limited to 8K. And also public services, we use AWS Bedrock, which is our basically AI as a service where we send the queries to. They run out of capacity relatively quickly. And when I was doing the work, I could only use US servers. Right, they since about a month or so, we can also do it in Frankfurt now, which is quite good news. Now, Outlook. So since we have this limitation of context size, when we try to add more capability onto these kind of systems, it becomes more and more necessary to actually break down the problem into smaller steps. And that's what is commonly called agents, right? You have basically AI-based agents which know about the tool set that they are given and can make use of these tools and execute it to a certain extent independently, right? At some point, you also still need to verify that what you have come up with is the correct way, but at least certain amounts of these tasks can be run independently from the user. And here I use this example, right? If you, for example, want to know how much are we exposed in Middle East, what do we mean with we? I guess the whole company then, every account. And we only have an endpoint to query for a particular account. We cannot do it for more than one at a time. Once it understands that in an agent model, it would then determine that it should loop over the accounts and do it many times in the backend, right? And then put together the information with the extraction part and in the end present it. So we are not there yet, right? You have basically right now something like a link generator, which you then have to deal with. It doesn't give you the 2% Asia allocations out of the box. You then still need to extract that yourself. So we have solved part of this problem, but to extend it, we need to start breaking it down. Okay, so that ends us with Q&A. Yep.
Michel, maybe for the purpose of understanding the work better, could you show how the context look like? So you've been talking a lot about providing the context, and I assume API specification is there, but you also created a lot of work around so the model understands the domain better, and maybe just a glance at the context would be an interesting one.
There's a bit of a delay on the screen, but this is actually the live system. Does anybody have a sample question to ask? Let's go out on a on an limb here, see whether it works.
Yeah, let's ask the ratings, allocation ratings.
Yeah.
101.
Okay. This is with a bit of delay, you will start seeing it stream in the response. See, it's starting to interpret. I understand you're looking for the ratings allocation breakdown. It already knew the account, so it's a fairly simple request. Thank you, Kevin, for making it easy on us. And one thing here is I could have selected actually the account already and the reporting APIs, and that influences the context given. So let me actually restart it now and enable an option called Language Model X-Ray. So when I reset the session and ask the same question again, then we can actually expand and see what was sent here. And since I didn't pre-select a filter, it's quite a lot of text, okay, that is being given to this model. So in a way, it's kind of astounding what it can do with so much text when in one query, right?
If I may interrupt you, since it's essentially what the robot sees, right?
Yeah, this is what
you ask a small sentence, but robot sees much more than that.
Exactly. The robot sees actually something where in the beginning it tells it, you know, the role that you have. You are an end user data retriever assistant. Your task is to generate an HTTP API request based on the provided list of API specification. So it's kind of tapping into the knowledge of a system analyst or like someone quite familiar with these technical terms, because the training data, as I said, hundreds of millions of dollars, it all contains that. It contains all the Stack Overflow knowledge, all the help knowledge from many questions that people had about systems like this, and it can infer a lot of that stuff, right? And then there's some information about date strategy, for example, like how do we arrive at the correct date to ask, and certain other edge cases that it deals with. It comes with abbreviations, because in the account names, in certain cases, we don't have certain terms. So for example, CBDEF, there's never something called CBDEF in an account name. That's why I say, look, if you find CBDEF, use CB001, because it didn't understand that before. It couldn't take the leap from CBDEF to CB defensive or CB global defensive. And then there is like the official account short names. We try to be as brief as possible here, actually, because again, context size limitations. If you add too much, it will increase the errors. And then for each API, so for example, here it knows about the fact sheet export, here about the product export, what parameters. And here finally, at some point, we get to the allocations. This was the allocation maturities. Maybe it's a bit up here. Here, there we go. That's the one we needed to use, allocations explore. It knows which accounts it accepts, because maybe some mandates are not linked in yet and so on. There's a lot going on here, okay? And in the end, it then just repeats what the user has asked for. Question, rating allocations BG 101. There's a little reminder, because again, attention, there was a common case where it fell back to the year 2023, because then the training data ended, and it kept thinking, wait, I have May 2024, so I count 1 month back. It's, oh yeah, it's April 2023. No, it's because it lost attention, right? It lost attention about the current date or how to exactly handle it. But if you hammer it home right at the end, then it kind of keeps it in the attention span. It's very interesting. It's almost like a human problem, right? Because imagine giving a person so much information to deal with, you know, he or she may forget about certain nuances from the beginning. So you just hammer it home one more time, like you do a presentation structure or onboarding structure, let's say. Never smoke at the gas station.
Do you think it has influence on the system if when you roll it out and people are interested in all at the same time? That's
I highly doubt it. And the reason is what we use in our reporting API, we call it Poseidon, is a so-called serverless framework, meaning from our point of view, we do not have to administrate and spin up additional servers. And for example, there is additional load. That's all done by AWS for us. So it just spins up as many instances as there are requests, and we just pay as we go. You know, a small, very small sub-percentage fee for each of these requests. And so, no, I don't think there will be any capacity problem. It spins up to 1,000 simultaneously, you know, even in the standard setting. And one request needs more than one, but still not 1,000, you know.
Look at the cost, it's fractions and fractions of one happened. It's request. even if we hammer it with reporting requests non-stop all the time, it will be in the magnitude maybe of $50 a month.
Yeah.